Hello guys, welcome once more to Class Online. I'm Tutor Dami, and in this video we are looking at Jamb Physics 2019, question number 41 to number 45. Now, are you ready for it? Now I'm ready to simplify it. And let's get to it now. Now, don't forget, if you really enjoyed this video, to click on like button so that we can get more content to you that will help you in your journey as you go. Now, let's check out number 41. It said a circuit contains three ammeters A1, A2, and A3 with readings A2 of A2 and A3 shown as indicated in the diagram. Determine the reading of A1. Now this is a circuit. Now you can see this circuit can deceive you a little because this is a parallel and a series circuit. This circuit, now how did I know? Now take a look at the circuit carefully. If you flow from this place, if current is flowing from this place, okay, I'm flowing this way. Now this is parallel. These two A1 and A2 are parallel because of one thing. As the current is flowing from this place, it can pass here. If you cut this line, if you cut off A1, if you take a knife and you cut A1 away, the current will still flow through A2, and the circuit will still complete, and there will still be current. Only A1 will be damaged. And parallel connection is that in which if you cut one, the others will still work. But series is such that if you cut it, everything will not work. Okay, like if you have three lamps and you cut one off, okay, if you cut off one, if the other two are working, that means it is a parallel connection. But if you cut one and everything goes off, that means it is a series connection. So if I cut this line of A1, the current will flow through the A2 and there will still be a complete circuit, and then it will still produce light in A2 and A3. But if I cut A2, okay, the current will flow through A1 and the circuit will still complete. There will be current in A1 and A3. But think of it, A3 is series because if I cut A3, even if the current flow through, if I cut A3, even if the current flow through A1 or A2, it will still need to pass through A3, and that's where the problem will be. All the lamp will not produce light because that A3 is in series, and you don't cut series guys. If you cut any guy who is in series, the entire lamp will not produce because these ones, A1 and A2, cannot complete without passing through the path of A3. So this A3 is series, while A1 and A2 are parallel. Now, the way we find the current for parallel connection and series connection vary. Now, I use this chart to just remind you. Now, if it is parallel, one thing that we must know for current that are in series is that series current are the same. Current flowing through anything series, it must be the same thing. That means we have 5 ampere for the series here. That's A3 is 5 ampere. That means all my workings for the others must also be 5 ampere because series are always the same on current. Now let's take a look at that. But when it comes to parallel, you have to add them up. You can see current for parallel need to be added up. You have to add the first and second. So I will start to find my answer for A3 by saying no, A1 and A2 are parallel. Why? Then we have parallel connection and series connection must be the same. That means the total parallel must be the same with the series. And of course, the series is 5. Okay, so if the total parallel must be the same with series, so I would say the two parallel must add up to 5 because they must be the same with the series because they are in the same circuit with the series. So that will become 2 ampere plus 1 ampere. That's 2A plus 1A plus A1 equals 5. So that will give me A1. That's the one I'm finding. That's the second parallel as 5 minus 2. Of course, the 2 will go back to the right hand side, and that will give me my answer as 3 ampere for the parallel. That's A1, and that gives me my answer as option B, 3 ampere. I believe you are able to understand that. Now let's take a look at number 42. Which of the following statement about magnetic line of force is not correct? Now you've been taught about magnetic field before, right? Now if you have not, this will help you to also remember now or to know it. Now we have they pass through. Now when I say magnetic line of force, I am talking about this thing. Now you can see one of the things about this thing is that it flows. That is the flux or the forces moving around the magnet, right? Now it flows from the north to the south. Can you see something about it? And it flows round. Now one thing that is common about it is that they flow from north to south. They don't intersect. As they are flowing, the first one will not cross the second one. They always flow on their own path. Then number 3, they form a closed loop. That means they always close. It will flow from north to south and finish at south. It must always close. So that's one thing. Now let's check out the option that is true. But the question says which one is not true. Now, A, they pass through even non-magnetic material. That means they can flow through non-magnetic material, and that's true. Do you know why that is true? If you put a magnet on a desk in school and you put a magnet below the desk, the magnet on the desk and the one below can still interface, because although the desk or the wooden table is not a magnetic material because it is not metal, but the magnetic force can pass through non-metal, and that's just what A is saying. They can pass through non-magnetic material, and that is true. B said run from the north pole to the south. That is true. It flows from north to south. That is super true. Then number C said are in a state of tension and tend to be shortened. Is that true? That is also true, because all forces are tensioned. Okay, that is also true. But D said they intersect each other. That is not true. They don't cross each other's paths. And that makes D the wrong answer and the criminal we are looking for. So D is therefore the answer. And let's see number 42. Number 43 says in which of the following activity is an induction coil not used? Now, when you hear about induction coil, you should be thinking of something. Is anything coming to your mind? Whatever comes to your mind must be in the line of electricity or electromagnetism. Okay, now which one is not useful, has nothing to do with electric current or electromagnetism? You can see that we have investigation of high voltage has to do with electricity. This one is just commonsensical. Now we have study of electric discharge is also having to do with electricity. An operation of X-ray tube. Does X-ray tube has to do with electricity? Then we have AC power transmission. AC power is all about power transmission. That's also having to do with electricity. Now I'm going to explain this soon in a very easy and a very straightforward way. Now we have what I have here is an induction coil or spark coil. Is a type of electrical transformer used to produce high voltage pulse from a low voltage direct current supply. Now this one is used to generate high voltage, like it's a type of step up transformer for voltage. That's what we call an induction coil. The reason why I said this is because I'm trying to make you know what is called an induction coil. It is a transformer, like a transformer that step up voltage from low to high voltage. That's the meaning of induction coil. But the question is not really asking for the meaning. I only define the meaning against if you were asked in any exam. Okay, now, but the question is saying which one is not used by an induction coil. Okay, we have investigation of high voltage. Because it has voltage, it is used because it has to do with electric charge. Now, study of electric discharge is also used. Now, AC power transmission, transmission, alternating current power is also under electricity, but the one that is not used is X-ray tube. Now, X-ray tube doesn't use anything called induction coil. That has nothing to do. Now, in fact, the topic X-ray is not under electric charge. Electricity. It is under what we call photoelectric effect. The topic X-ray is under photoelectric effect. That means it is under atomic physics. It's not or nuclear physics. It is not under electric current. So the topic X-ray has nothing to do with induction coil, and that makes him the criminal that is hiding that we are looking for. So the one that is not among the guys is X-ray tube, and that is my answer, option C. Now let's check out number 44. Now so we have in a series RLC circuit, R is what 10 ohms. Then the positive reactance is 4 ohms, and my XL, which is inductive reactance, is 9 ohms. The impedance of the circuit is what? Now you must know what this guys mean. We have in a series RLC circuit. Now this is a series RLC circuit, right? Then we have resistance, please. Resistance as 10 ohm. Then I have capacitive reactance as 4 ohm, and we have inductive reactance as 9 ohm. The impedance of the circuit is what? Now this topic is under simple alternating circuit. This topic is under AC circuit. Now, whenever you hear the word impedance for RLC circuit, this is the formula to use. Now, the formula for impedance, that's the one I have in yellow, is root R squared plus XL minus XC. Don't forget, whenever you are asked to give the impedance of a simple, of a RLC circuit in series, this is the formula. Z equals root R squared plus XL minus XC, where my Z is impedance, my R squared, my R is resistance, my XC is capacitive reactance, and my XL is inductive reactance. And that is it. Now let's put in all the values. We have to find our impedance. We have been giving every other values there. So putting the value to the formula, we have root my R squared, which is my resistance, is given to me as 10 ohms. So that's 10 squared plus my XL, which is inductive reactance, is 9 ohms. And that's my 9 minus my capacitive reactance, which is 4 ohms. All in brackets squared. Okay. Okay, so let's go. So Z equals root 10 squared is 100 plus 9 minus 4 is 5 squared. Okay, so we have root 100 plus 25. That gives me root 125. If you punch that on your calculator, you'll be getting your impedance Z as 11.2 ohms. And that is my answer, 11.2 ohms. Don't forget, most importantly, is the formula. The formula Z equals root R squared plus XL minus XC. And that is the formula for finding impedance in an AC circuit. Don't forget. Now, that's section number 44. Now, let's take out the last question for this video. Oh, unfortunately, number 45 is not accessible. That means we have no 45 in the past question. So that means I'm going to stop here now. Okay, so guys, until we see next time, don't forget, if you like this video, click on the like button. Then we'll get more material that will help you in your journey of understanding physics. Take care of yourself and bye for now.